Good afternoon, everyone. Let's try this question. A 0.48 gram sample of calcium carbonate react with a 50 centimeter cube of a 0.11 mole per cubic decimeters of nitric acid solution according to the balanced equation given below. So we have the balanced equation, which is this one, and then the question says calculate the percentage purity of the calcium carbonate, which is CaCO3. So what are we going to do? We are given the concentration and the volume of the nitric acid, which is this one. So what are we going to do? First, we're going to calculate the number of moles of nitric acid. That's the first step. So we start. Let's check first. The volume is given in cubic centimeters. So to convert that, let's say we just take 50, we divide by 1000. Then this is going to give us 0.05 cubic decimeters. So it means that now the volume is 0.05 cubic decimeters. So let's start. We're going to calculate the number of moles of nitric acid. So number of moles, nitric acid is HNO3 is equals to concentration multiplied by volume. So you remember we have the formula concentration is equal to number of moles over volume. So we just cross multiply and then N become C multiplied by V. So it's the same formula as that one. So now let's check. What is the concentration of nitric acid? We are given the concentration as 0.01. So let's say 0.11. 0.11. Then what is the volume? The volume is 0.05. The converted one. So 0.05. So when we punch the calculator, this is what we get. We get 5.5 times 10 to the negative 3 mole of nitric acid. Now let's check. Let's go back to the reaction. We have what? We have nitric acid is 2 calcium carbonate. So look at the ratio. Nitric acid is 2, calcium carbonate is 1. So for us to get the number of moles of calcium carbonate, it means that we're going to take the number of moles of nitric acid, then we divide by 2. Then the answer is the number of moles of calcium carbonate. So we are going to say number of moles of calcium carbonate is equals to the 1 over 2 the number of moles of nitric acid. So why? Because look at the ratio. Calcium carbonate is 1, nitric acid is 2. So for us to get the number of moles of this, we have to divide by 2. So now 1 over 2, 5.5 times 10 to the negative 3, which is, this is giving us 0.00275 times 10 to the negative 3 mole. So now this one is the number of moles of calcium carbonate. Now from here, let's say now we're going to calculate the mass of calcium carbonate. Since we have the number of moles of calcium carbonate, now we're going to calculate the mass of calcium carbonate. So number of moles, let's say we use this formula, number of moles is equals to mass over molar mass. So let's change this before we start calculating. So we're going to say mass, we cross multiply, is equal to number of moles multiplied by the molar mass. So what is the number of moles? The number of moles is this one, we calculated So it's 0.00275 times 10 to the negative 3. Then what is the molar mass? The molar mass, we get it from the periodic table. So let's say we have the periodic table. We're talking about calcium carbonate. So we check where is Ca. Ca is in group number 2. So here is Ca. The molar mass of Ca is 40. So we're going to say this is 40 plus. Then what is the molar mass of carbon? Carbon is in group number 14. So this is carbon. It has 12 molar mass. So we're going to say it's 40 plus 12. Then plus, what is the molar mass of oxygen? Oxygen is in group number 16. So we have 16 molar mass of oxygen. But remember, oxygen is O3. That means we have 3 oxygens. So we're going to say 16 multiplied by 3. So now what are we going to get? So let's say this is 0.00275 multiplied by 10 to the negative 3. Then when we add this, it gives us 100. 100. So when we multiply 100 multiplied by that, we get 0.275 grams. So now let's go back to the question. Now we have the mass of calcium carbonate, which is CaCO3. The question said, calculate the percentage purity of the calcium carbonate. So what are we going to say? We're going to say the percentage, let's say the percentage of calcium carbonate is equals to let's say the mass of pure substance. Let me say pure substance divide by the mass of impure substance. Impure substance. So now the mass of the pure substance is the one that we calculated. So this is the pure substance, which is 0. Oh, sorry, this one we multiply by 100 since we are looking for the percentage. So the mass that we calculated is our pure substance. So this is 0.275 divide. The impure substance is the given mass from the statement, which is 0.48. So we're going to say 0.48, then we multiply by 100%. So now what do we get? The answer is 57.29%. So this is the percentage purity of the calcium carbonate. So that's it. So if you haven't subscribed, please subscribe, and thank you.